determine if the series is absolutely convergent, conditionally convergent, or divergent. Okay, let's take the absolute value. Then we get n from 1 through infinity, absolute value of this n plus 1, that keeps negative, positive, negative, positive, 2n minus 1 over 3n minus 1. That is just a series of positive terms, so this one is gone. So we get 2 raised to n minus 1 over 3 raised to n minus 1. When n equals 1, this is 2 raised to 1, 2 minus 1 is 1, so all the terms are positive. Okay, so we have a series 2n minus 1 over 3n minus 1. Okay, now we want to show if this series converges. Okay, looks like 2n minus 1, 3n minus 1, 2n is the leading term on the top, 3 raised to n is the leading term, and when n goes to infinity, okay, it will be 2/3 n, that goes to 0, so we cannot use the test for divergence. Now let's say this is an, this part is an, and we want to compare this with another known series. Okay, let an be 2n minus 1 over 3n minus 1, and we want to create a series with terms bn that we can compare with an. Just consider the leading terms, so 2n over 3n, which is same as 2/3 n, and when we make a series bn, series 2/3 n, this will be a geometric series with ratio 2/3 less than 1, then the geometric series converges. Okay, now we want to compare an and bn, so we use limit comparison test. Now limit of an over bn when n goes to infinity is n goes to infinity an 2n minus 1 over 3n minus 1 divided by bn. Let me write this form, 2n over 3n, which is same as limit n goes to infinity 2n minus 1 over 3n minus 1, this division to multiplication, flip this fraction, that is same as limit n goes to infinity, distribute, and this is infinite limit. The only terms matter are the leading terms, so when we multiply 3n 2n, it will be 6 raised to n minus 3n, that's a smaller term, we don't have to consider, just consider the limit of leading terms. Same thing, 6n, okay, 6n cancel, just 1, which is positive and finite. That means the series with an, that means this series, and the series with bn behave the same. Both series converge or diverge. What do we know about bn? Since the series bn, n from 1 through infinity, which is n from 1 through infinity 2/3 n, this is a geometric series with common ratio 2/3 less than 1. Since this converges, being a geometric series with the ratio 2/3 less than 1, since this converges, the series with an, that's what we're looking for, an, we're trying to check the convergence for this one, 2n minus 1 over 3n minus 1, 2n minus 1 over 3n minus 1, also converges. Okay, that means this series, when we take the absolute value, we get this series, and we just showed this series converges. That means this series converges absolutely, or this series is absolutely convergent. Okay, so this is absolutely convergent, because when we take the absolute value, we got this series, we compared with this series, and we found this series converges. That means this series is absolutely convergent, or this series converges absolutely.